All right, so our next shape is trigonal planar. This is going to introduce a kind of new concept here. We have two types of geometries or two types of shapes that we talk about. We have the electron geometry, which is when we talk about the shape and we include the lone pairs when talking about how it's shaped. And then there's the molecular geometry. And here we think about the shape, but we ignore the lone pairs. The lone pairs are still there and they still help to determine the shape, but we don't talk about it when we're talking about what the molecule looks like. Overall, the molecular geometry is much more common. So if you're ever asked just for shape of a molecule or the geometry of a molecule and they don't specify whether it's electron or molecular geometry, they're talking about molecular geometry. So anyways, where we're at in the chart right now is we are at 3 electron dense areas. We can see that the electron pair geometry here is trigonal planar. And that makes sense. If we had a molecule with 3 things attached to it, the way that we would get everything as far apart as possible is to arrange them in kind of this triangle, right? All of these bond angles are 120 degrees. And again, this is called trigonal planar. Right, so the electron geometry is trigonal planar. If it has no lone pairs, the molecular geometry is also trigonal planar. So BH3 is an example of this. Or something like formaldehyde. You can see that central carbon has 3 things attached to it, none of which are lone pairs. Note that double bonds repel more than single bonds. And so if you took a look at this bond angle right here, it'd be slightly greater than 120 degrees because that double bond is repelling more than a single bond. And that makes sense. Double bonds have more electrons than. All right, so the next thing in our chart, we can think about replacing some of these atoms with lone pairs. So if we have 3 electron dense areas, one of which is a lone pair, you can see that the shape then is bent. And so when we draw out the shape, if you think about the lone pair, you can see these two are essentially the same shape, but now we're just not considering this lone pair. And so we're only like kind of looking at this molecule part of it, and it looks like it's bent. Overall, an electron pair repels more than a bond. So if you think about these bond angles here, over here, it'd be over 120 degrees, and thus this would be slightly less than 120 degrees. And again, this molecular geometry here is bent. Its electron geometry is still trigonal planar, right? So electron geometry, trigonal planar, molecular geometry, bent. An example of this is SO2. Boom. And a lone pair repels more than double or triple bonds.